Yeah. Hello all. I'm audible.
Yes.
Yes, sir.
Yeah. Thanks. Yeah. So we'll start this session. So welcome all to this week three live problem solving session. So in this session, we primarily discuss the questions about the naive Bayes classifier. So as in this lectures, in this week lecture, which is about the naive Bayes classifier, Dr. Pavitra has taken one example which is discussed throughout this lecture. So that example is an fish classification, right? That you can take any other example as well, but that is an simple to understand, or example has been taken. So the example has been taken to we have a length, a different length of the fish, and we need to classify based on the length. So that particular fish belongs to which class. So there has been taken two classes. The one is an hilsa fish and tuna fish. So given an length of a fish, the machine or we need to classify that particular fish is an tuna or hilsa fish, right? So from the beginning, there we have seen the class conditional distribution. So where the two distributions we have got actually, that is based on the classes, right? For each class, there is a class conditional distributions are there. So on the x-axis, different length of the hilsa fish length is there, and on the y-axis there is a probability of particular size of the or length of the fish has been occurred, right? Or probability of particular size of the fish is occurred in that hilsa fish, right? So that we have saw in the distribution of the, and then we discussed about the how we can classify these two, how we can classify the length of the, based on the length of the fish we can identify which one is the which length is belongs to which class of the fish, it is a tuna or what we can say, the hilsa, right? So for that we have taken a two distribution, we have merged in a one plot, right? And in that plot we are trying to identify that best boundary decision line, that, so I will draw here, so that we have seen this two distribution like this one and this one, right? So this belongs to a hilsa fish and this belongs to a tuna fish, right? And we tried so in the lecture there has been taken multiple scenarios. If the boundary line is here, then what is the error we are getting, right? How much error we are getting? So this much is an error actually, right? So this much is an error. Suppose we are drawing line here, then this much is an error, right? This up to this and this one. So we will try to find a best fit line over here, which is an class conditional probability. At this point it is same, right? Equal, right? So but here there is an one problem in this taking taking this scenario. The first is, and there is an this much as an error is we are getting while taking the best fit best decision boundary here, right? For this line. Another is, and suppose as taken one example, that is, and suppose we have collected samples of the fish, right, in the monsoon in Calcutta. So there is an hilsa field sample is very high, and if we have collected at the same season, the tuna fish sample is very less. The collection of the tuna fish is very less. So here we are getting the boundary line is here shifted here, right? But the actual, if we have taken the same number of balanced samples, then maybe we are getting that best fit line like this way, right? This is the one disadvantage we found there in the best fit line, best fit boundary, taking the boundary line. So we have comes into one uh, another formula that we have to scale it out. This small number of samples we need to scale it out based on the probability of the particular class. That probability we are calling as an a priori probability, which is the probability about only the class. In that, uh, we are not explicitly considering the length of the fish, right? Explicitly class means, so how many in the overall class, in the collection of overall fish, how many are the hilsa fish, right? The probability of the hilsa fish and the probability of the uh, tuna fish. These are this probably a priori probability we have uh, multiplied to the class conditional probability, right? Then we are getting another probability. So that condition is, this question is related to that particular concept. So please read a question and please try to give an answer for this question. Which one is an correct option for this question? Please read this question carefully and please let me know which one is an correct option for this. So whatever we have discussed, which is about this question actually, prior to so to resolve this problem, we have evaluated, or we have known and one a probability. Based on that probability, how we can identify, or we can assign a class, correct class to a particular instance. Yeah. So someone is saying an A option. Is there any other correct options are there? Yeah. Yeah. So the correct option is A. Before that, I will read the question again. So here the question states that in a multi-class classification problem, base classifier assigns an instance to the class corresponding to which probability. So here there are different four possibility of the probability has been given. The first one is a maximum a posteriori probability. The B option is that maximum a priori probability. Lowest C option is an lowest a posterior probability. D is an lowest a priori probability. So as we discussed here, some samples are less as compared to the another class. We need to scale it out, right? So we are scaling it based on the a priori probability, right? So here we have a distribution conditional. So here we have the distribution of the class conditional probability and for the respective class, and we are scaling it out based on the by multiplying the a priori probability, which has explicitly discussed in the lecture, which is an, suppose let's take as an this one second. Suppose we have a class conditional probability, which is an about, this is an length given uh, for a particular length, and given the class is an hilsa, what is the probability of this length is belongs to hilsa class, right? And this is an class conditional probability we have multiplied by with the a priori probability, which is about the probability about the hilsa fish, which is evaluated based on the number of samples. It's irrespective of the length, right? And this is the class conditional probability we have considered, and then so based on this probability we are trying to find that for, so this is for the hilsa class, right? So suppose the length is and 1 feet, and given that this fish is and the probability of hilsa, what is the probability of the hilsa to given this length actually, right? That we need to find out. So this is then for hilsa fish class probability, and another is an L is equal to 1.2. Then what is the probability given that this is an tuna fish, and then we have multiplied by with the tuna probability. So this term, this probability we are calling as an uh, maximum posteriori probability, posteriori probability, right? Map. So here as we have saw, this is an two distribution, right? This one is an two distributions are there. So here we have considered, previously we have considered a boundary decision line, right? That is a best fit line, we can say that. And so where the errors are less. So here we are considering, so be, prior to this line, means and on the left side of this line, we are considering this, which is an Hilsa class, right? And beyond this line, which is an Tuna class, which is an explicitly or strict rule we are applying here, right? And here there are multiple errors we are getting right here. But as considering the map, which is a maximum a posteriori probability, where we are, how we are classifying the, or how we are assigning the class to a particular length of fish. So here suppose this two distribution there, and suppose we want a 1.2 feet is here, right? So for this 1 feet, so this 1 feet fish belongs to which class? We need to find out based on the a map probability. This is a maximum probability. So we need to get the probability for this Hilsa. This is the Hilsa distribution, and this is for the uh, tuna fish. So we are getting the map probability for Hilsa, right? And probability for the tuna. This is a map actually. I have written like this a priori likewise, but understand that. Okay. Then we need to compare it. Which one is the greater? This probability is greater or this probability get greater. So here you can see the probability of the Hilsa for this 1.2 feet fish is an higher than this uh, tuna fish probability for this particular 1.0 feet, right? So here likewise we are classifying it, right? So here the error is less as compared to the taking considering a strict rule by applying a decision best fit decision on the distribution. Yeah. Okay, I hope you guys understood that why the first option is correct, and that's all. So that's why it is considering as a maximum a posteriori probability. So based on the maximum, which one is the maximum probability, a posteriori probability? So based on that we are assigning a class, right? Okay, let's move to the another question. So this is also simple question that we have that is also explicitly discussed in the lecture. So please read this question carefully, and please try to analyze that which option is correct for this question. So in lecture, so okay. So any guess for this question, or if you have not found any correct answer or any, you may take a guess also. Just yeah, maybe yeah. Let's take as in that it is an maybe or it should be B option. Yes, any another possible option is there? D. Someone is saying that all of the options are correct, incorrect. Here, the nominal represents an categorical actually. Okay, categorical, or we can take as an explicit classes are there. The numeric which is and continuous values are there. The attributes include the continuous values, as we have considered in our example, that is a length of the fish, right, which is a numeric values, right? It is an continuous values, right? It is not as in categories, right? Yes, no, or any high, low classes. These are the attributes. Okay, let it be. So yeah, we'll discuss this later. So here the question states that which of the following is an incorrect about the naive Bayes classifier. As we have saw that, so what the first option states that attributes can be a nominal or a numeric, right? So attributes means what, right? So this we have discussed in on our that previous decision tree lectures, and also before that, that is an mm, a priori algorithm or any that is association rules, right? So attributes, there is an multiple attributes are there, attribute 1, attribute 2, and there is an target attribute is there, so that we need to classify. So means suppose you have given a in our considering that simple to understand, considering attribute 1 is a length of the fish. The length of the fish represented as one independent attribute. Okay. And so for this particular length, what is the class of this is the target attribute, which is about the hilsa or tuna, right? So for length 2, length 4, the class is an hilsa, likewise, right? So this length of the fish, which are represented in a numeric values, which are continuous values are there, right? Some means we can say, or the another attribute maybe we can consider, this attribute hilsa will be survive in hot or it is an cold, likewise. So it is an some example, potential example I'm taking here. Okay, likewise, so based on this attribute we are trying to identify for a particular set of attributes what could be the class uh, these attributes are associated, right? So this option is correct, right? We have taken a numeric value here, that is to classify that particular numerical value, that particular length, it belongs to which class, class hilsa or class tuna, right? Also it is a nominal. We have taken one example that me that you may recall, that that is a mammal classification in the lecture. The one example has been taken, that particular instance of the there are multiple attributes are there, as snow or hot or cold or low or high. So considering the set of the attributes, we are trying to identify a class which is an mammal or not mammal. So in that particular example, we have taken a nominal attributes, right? Yes, no, which are the distinct in the case, we can say that. So this option is correct. It's not an incorrect. And the B option states that attributes are statistically dependent on one another, given the class value. So this is not true. We in the naive bias, all the attributes it assumes that it is an independent. That's why we are considering for probability A intersection B, it is an probability of A into B. So based on this independent case, suppose it isn't true, then it is not true, right? So that's why it is incorrect. This option is incorrect. Attributes are equally likely. So maybe this condition or this option may be eligible. Like if a probability are a prior probability are uniformly distributed, then in that case these attributes may be equally likely, right? But this is not always assumed, right? So naive Bayes primarily focuses on conditional independence actually. Okay. So this is the true, okay, in some cases, right? So obviously this option is not correct then. So this option is incorrect. The statistically dependent attributes are not there actually. It is an independent attributes are. Okay. Yeah, I hope you guys understood, right? So whatever we have discussed, which is explicitly we have studied in the lecture, that the nominal, if attributes are nominal, that example we have considered, which is an that particular hilsa classification or tuna classification. For a numeric attributes, the example has been discussed, which is an that particular set of attributes which is belongs to mammal or not mammal. So for classifying the mammal or non-mammal, we have say considered a set of features which are this each feature, which are the nominal as a category. Actually, nominal means which is are distinct in values. Classes are there means there is a different, like let's take as an high or low. That suppose it is an uh, the sunset, or what is the temperature. It is, let's take as a temperature attribute. So there is an two values of in belongs to that attributes: high, low, cold or hot. Likewise, yes, no. Okay. Yeah. Yeah. Let's move to the another question. Next question. Yeah. So this is also a simple question. So yeah, try to read this question carefully and try to solve this question. And after a few minutes, we will solve it anyway. But please try yourself firstly. Okay. Please read the question carefully. Okay, I will read the question. A fair coin is tossed n times. The probability that the difference between the number of heads and number of tails is n minus 3. So what is the probability for that? There are four options are given. So you can choose any correct options. So anyone found any correct answer? Or you may take on a guess if you not found the correct option. Okay. So we'll try to solve this question. So this is an fair coin which is tossed in at number of n times. We need to find that what is the probability that the difference between the number of heads and the tail is n minus 3. So here assume that let uh, h be the number of heads we found. Okay, head. And so the obvious thing is that n minus h is an number of tails, right? We are getting. So here, we need to find the probability of the difference between the number of heads and the. Yeah, someone is saying 0. Let's figure it out. It is an 0 or any other values. Yeah. So maybe it's not visible correctly. Okay. So here, assume that h is a number of heads. Okay. And n minus h is an uh, tails, number of tails we found. Okay. So we need to find the difference between the number of heads and the number of tails. So like similar, it's n minus h, right? Second, 1 minus h is equal to n minus 3 we are getting, right? So here you can solve this question, then we are getting a equation like 2n minus 3 divided by 2, right? So yeah, divided by 3. So after solving this question, you will get n divided by n minus 3 divided by 2. So considering this value for the h, it is an goes to a float value, right? Means it is an not is an integer. That's why we are getting as an the probability which is an zero probability. If it's not an integer value we are getting here, right? So it should be a number, should be a integer value, right? Yeah. I hope you guys understood, right? Yes, anyone has any doubts here? Okay, not yeah, okay, I will repeat here. So here we have considered h a variable as an number of heads here, right? And we have total number of times are there, right? Total uh, number of coins we have tossed, that is an n, right? So h, suppose we have considered as an head, number of heads, we have incident, then n minus h as obviously represented as an tails, right? Number of tails. So we have taken their difference, which is an n minus h. Sorry, this is an h actually. So h minus n minus h. So this is an head and this is an tail. That probability we want, right? And that probability has that means that mention that it is an n minus three. That there is a difference between the head and number of heads and number of tails, which is an n minus three. So after resolving this question, you will get this equation, right? So here h is equal to 2n minus 3 divided by 2. Okay. After resolving this further, then we are getting as an n minus, so this is an n, okay. So don't confuse about the n and h. N minus 3 divided by 2, which is a not explicitly integer value, right? That's why the probability for the difference is n 0. Okay. Yeah. Okay, let's move to the another question. So this is about the conditional probability. You need to find that. So I will read a question for you. The question 4, it states that three companies supply bulbs, right? So the company names are A, B, C. The percentage of bulbs supplied by them has been given in the second column, and the probability of them being defective. Okay, from the 60 percentage of the supplied bulbs by company A, with the probability of defective is 9.01. Okay, given this data, needs to identify that given that the bulb is defective probability. Okay, bulb is a defective, and then that is it's supplied by B. Okay, so here we need to find that probability of B, probability of company B supplied given by uh, it is an defective. So please try to understand the question and try to solve this question. Okay. So I uh, may simplify this question by writing a which probability we need to find. That is, and we need to find the probability of a company of B supplied, company B supplied, given that the it is an defective. So 1 second. Given that it is an defective, right? This needs to solve by a Bayes theorem, which is based on the conditional probability. Yeah, let me know which one is the correct option. Okay. Yeah. So why we are solving this question? So this is the base of our naive Bayes classifier. So which will help you to how will you will get an how the naive Bayes classifier works actually. Okay. That's why it is an important to understand this type of the questions. Yeah. Anyone has got the answer? Okay, let it be. I will try to solve this question. Okay, let me read the question. So, yeah. So yeah, the three companies supply bulbs, right? The percentage of bulbs supplied by them and the probability of them being defective is given below here. Okay, and you can see the company three companies has been given for each company the percentage of the bulbs they have supplied, and from the supplied bulbs how many have been got as a defective, the probability of getting a defective bulbs for company B, C. Right? Given that, uh, yeah, yeah, it's correct answer. Let's see if it is correct or no. So, is anyone other than this Wongdik got anyone answer for this question? Anushka is saying point two. Okay. Yeah. Okay. Let's see which one, which answer is correct. It is an point two or point four. It is given by students. Let's see which one is incorrect. Okay. So given that the bulb is defective, the probability that is and supplied by B, we need to calculate. That means the probability, let's write it here. Maybe you have note down the table information. Okay. So here the probability of the company has been supplied, B company has a supplied, and given that it is an probability of defective. So as we know that it is an uh, Bayesian conditional probability, which is a probability of uh, it is a defective and supplied by a B into a priori probability, which is an probability of B. Okay. So this one and the this one, it is an multiplied by probability of D is an equivalent, right? That we have saw in the lecture. So by simplifying it, so we are getting then probability of B given D. The B is in company supplied and D is an defective. Okay, probability of D given by B. Right. So into probability of B, and here the probability of D comes here, that we need to, because we need to identify the probability of B given D. Okay. So let's calculate on the B probability of, sorry, here we need to calculate the probability of the defective given by B company, and what is the a priori probability of um, a priori probability of the B. Okay. So for this, so D probability of defective given B. So that is, we have that probability, right? The company B and the probability is defective is in point not 2, right? So we have already this probability. Then we need to identify the probability of the B. So probability of the B supplied, which is an 30. So after calculating the probability by 30 divided by the total number of the supplied, which is about, we are getting is in zero point 0.3, right? So the value maybe it is in point not 6. Yeah, it's correct. Okay, let's move to about the probability of defective. So the overall defective probability we have not got, right? So what we have to do for this probability of defective, given that given that probability is by company A, and as this is an conditional probability, so we need to multiply by supplied of A, how many supplied, based on that how many it got is an defective, right? So for this all the company we need to get this defective probability, given that it is an supplied by uh, A company or B company, sorry, here it is a B company. Okay, plus probability of D given that it is supplied by a C company. Okay. So here you will put these values. So as this value given by A, it is an this value has been given here, right? The point not one, right? Point not one into, right, point not one, and probability of A it is an 60%, that is an point 0.6, right? Point 0.6, and it is point not two for B, or point 0.3, point 1, sorry, this is in point not 3, point not 3 defective given by company C into point 1. So if you calculate it, so how much the value we are getting for this? Yeah, 0.45. Okay, maybe it's the value it's getting is an point not 0.15, right? Let's divide this value, the probability of defective. So how we are doing that is, and we need to divide by point not 6 divided by 0.015. Yeah, 0.015. So you're getting as an point 0.4, right? It's an correct answer for this question. So the option 4 is correct here. I hope you guys understood, right? Hmm. Okay, let's move to the another question. Hmm. Yeah, please read this question carefully and please try to analyze that which one is the correct answer for this question. Yeah, yeah. Someone is saying an A option. Any another answer has got anyone? Yeah, 2 divided by 3. Two students are stating. Yes, any other answer is there? Not denoted. B. Okay, yeah, majorly saying that the B option is correct. Let's see which one is option correct. Someone has said already that A option could be the correct. Let's see the A, B, or none of this correct. Let's say. Yeah. So, so here we need to identify that. So here the we have given information about the probability of z intersection and x is equal to zero point 0.5 zero point 0.2. The intersection means the both these events has occurred or incident put together. Okay, and this is an independent x occurrences or probability of x occurs, and this is an y occurs. So the probability y occurs meaning y always happens. The one is means y always true. Okay. So we need to identify that what is the probability of z given that x and y both are incident together. Okay. So as we know that the definition of the conditional probability as considering this z given that given by x intersection y. I hope what is exactly intersection means is here, right? That means these two events has incident or occurred both together. Okay. So the conditional probability states that we have also seen uh, in the association rule. Maybe you can map this thing x there. Maybe okay, it's fine. Let's maybe independently see this conditional probability how we have seen. So here the conditional probability is that z intersection uh, x intersection y given divided by probability of x intersection y, right? So as this we know that, right? So this here you may observe that the probability of y is given 1. That means this y is always true, always happens, right? Always true. That means the probability of, suppose let's take as an any a value, a event and y event both incident together, and here considering the probability of y is equal to 1. So in this case, this should be a probability of a, because always y isn't true, it always happens. We can write it like this way as well. So considering this phenomena, we can apply it our p of that this intersection and this intersection. Okay. So these terms transform it like that. So z intersection x intersection y, it goes to probability of z intersection x, right? So this one, another reason, probability of x intersection y is equal to probability of x, right? I hope you guys understood. So you can observe this, both these values has already given this our question, so that this option is already gone. Let's see this 3a, b and d option, right? Okay, you can directly put these values in our equation. Okay, so the equation values, maybe we have a like uh, I can write here the probability of z given that x intersection y. So here the for revised formula is that probability of x z intersection x divided by probability of x. You can simply put the values zero point 0.2 and zero point 0.3. So we are getting 2 divided by 3. So this one is an correct option. So that is an B option is correct. Yeah, many students has got this answer already. Yeah, that's true. I hope you guys understood, right? Okay, let's move to the another question. Okay, please write down this table, so that based on this table we are discussing the questions. Okay, there are two questions are remaining, so we'll discuss these questions on based on this uh, data. Okay, please write down this table so we can refer this table in further questions. Okay. So everyone has write down this table or still writing it? Okay, I hope you guys written this table. Let's move to the another question. Yeah. So please read this question carefully and try to solve that, so that given this condition, that is in GPA high, the student effort is somewhat some is thing means it's they has given us some efforts, confidence particular student is and is yes. So given this condition, it is hired or not hired, that we need to find out. Yeah, you may take us some time and please try to solve this question, so that we'll get to know that that particular person will hired or not. Yes, someone saying that it is an B option. It is not hired. Let's see if it is hired or not hired. Both classes are equally likely. B, someone saying B is no. Yeah, majorly saying the B and D. Any other option is correct. D. So it is an equal. Here is also equal likely actually. Both options, though two options are we got as an B and two options. Two responses are D options. So here is tie. So please give anyone answer, so that we can resolve this tie. Okay. Otherwise, we will also discuss anyway. Okay. Yeah. So GPA is high and effort is some. It's not as in lot efforts. Confidence is S. Is there any possibility of another option? Others may take a guess if you are not got the correct option. As we have seen this type of the question in the lecture related to the particular instance is an mammal or not mammal. In that discussion, this type of the question has been discussed. So maybe you will recall that. Okay, let's move to the solution of the. Let's discuss this question instead. So here we need to find out that probability of. So the naive Bayes classifies based on the conditional probability, right? That we have maybe observed, that you have said, right? So it is based on a probability, specifically on the conditional probability. Right? So here we have to uh, identify that given this many features, feature 1, feature 2, feature 3, what is the probability of these features with specific conditions belongs to higher class, right? And also we need to quantify a probability given the same condition of the features, right? These features represents that is an GPA or confidence or what is an efforts, right? So the GPA is high, efforts is some, and F2 is that is an sorry F3 is an what we can say that is confidence is S. Given this condition, what is the probability for it is not hired? So we will compare these two probability. Which one is the higher? Based on that, we will assign the label for particular these conditions. Are you getting? Okay. Okay. Let's move to the conditional probability. Okay. So we know that the neo Bayes classifier is based on the conditional probability. The probability of conditional, which is if we have a class given that these many of features, okay, given that these many of features, we need to find this could how we are representing this in a conditional probability, right? So this is a probability of class independence, class distribution, class independent probability, which is a feature given that this class into probability of a class divided by probability of a feature, right? So since we are only comparing here the probabilities for a different classes, we can ignore this feature probability. Okay. So we can directly write here the class probability given that this feature is directly proportional to the probability of what you can say probability of uh, this feature given class to PC, right? So considering this phenomena, we try to solve this question. Okay, as you may uh, have written the what we can say, write that table. So considering the table, we will put these values. So specifically, we have to the PC. So I will try to write explicit equation for this. Which one? The first equation that we need to find the probability given this condition, specific condition. What is the probability of this event is belongs to a higher class. It should be higher is an S. That is an probability of GPA is equal to high. Also, efforts is equal to sum. Also, the confidence is equal to high, right? High, yes. Confidence is yes. Given that it is an uh, higher, it is equal to S, right? So this probability first we need to calculate into the probability of higher. So this term we need to calculate. The second is that probability of, so it is giving as an, it got as an probability of that this thing, right? The probability of class given these features. So here also the same condition, ES confidence is S, given that higher is not equal is N, right? That means it is not hired into probability of not hired. How much the, right? Yeah. So I hope you guys understood these terminologies, and based on this, we need to put the values in it only. So this we need to break it down. That previous example we have done. Before that, we will find the probability of hired and non-hired. Okay. So here I will write. Okay. Yeah. Here I can save the space. So higher probability is, we need to how we can find how many times it is an yes. 1 2 3 out of 1 2 3 4 5, yeah, 3 times s. So the higher probability 3 divided by 5, right? And it is non hired not hired, which is an 2 divided by 5. right? I hope you guys understood till now, right? So further we need to calculate a probability of each of these terms. Okay. So how we can calculate? Let's try for the first one, that is an probability of G is equal to H, given that it is an higher, into probability of, right? So let me know if I'm going a wrong direction or any different direction. Let me know. Okay. Yeah. So here we have, let's say, hmm, we are finding the probability of H given this, and then the probability of sorry, so what is effort is equal to sum, and given that it is higher, into the probability of uh, confidence is S, given that it is higher, right? So this probability we are trying to get for each of the class, for S class, right? So how many S are there here? One, two, three. So for each of the attribute, we need to identify for S, for total number of S is here is 3, right? N is equal to 2, right? From out of 3 samples, how many GPA is high? You can see this one is no, the 2 samples is a high, right? 2 GPA. So for this, it is, and we are getting is an 2 divided by 3 into, for E sum, for S you can see only one here, right? This for is a no. How many times sum is getting? For one time for S, right? So 3, why I'm taking the 3 denominator? Because we need to find from the S samples. So whatever S samples are there, higher samples are there, and from that higher samples, how many are the GPA high, how many efforts are sum, right? So here we are getting as an 1 divided by 3 into uh, the C is equal to Y S, confidence is equal to S. How many we are getting? It is also 2, right? 2 we are getting, right? 2 divided by 3. So from this we are getting a total. So this is for equation 1, right? So which is about 4 divided by 27. We need to multiply with this equal to S probability, this one probability, right? This you can see here we have following this equation 1, right? 3 divided by 5. So what is then answer for this? 4 divided 37, which is about 12, and this is an 135. After solving this, we are getting as an 4 divided by 45, right? So this is for a S class, higher, it is high. Based on only this term, this probability, we can't decide it belongs to a higher class or not higher class, right? We need to also identify the same methodology applying. We need to identify the no class. Okay. So I'm not writing these explicit terms here, but we can write our values. Okay. Here for the equation 2, I'm following this equation in the equation 2. Okay. So similar way for the no, how many is an high? We need to identify that. How many it is an high for no. No samples are 2 only here. 1, 2. And it is an high. We are getting high for one time only. So 1 divided by 2. Right? 1 divided by 2 into sum is uh, effort is a sum. For no, effort is sum is one time we are getting. So here 1 divided by 2 as well. Right? For confidence is S, N is equal to S, we are getting only one time. Also for 1 divided by 2. Okay. So after multiplying it, we are getting as a 1 divided by 8. So this is only the probability of this conditional probability, this one up to this. Then we are need to multiply with this no probability, 2 divided by 5, right? Then we are getting as an 2 divided by 40, right? And it is an 120. So this is a for no class, hired is not hired, not hired, and it is hired. So which one is a greater probability? Higher, right? This one is a greater. So the option is higher. It is A option is correct here. Yes. Have you understood? Is there any doubt here? So anyone has any doubts or got the how we are calculating the conditional probability here? Yes, any doubts? Okay. If not, then we can move to the another question. Okay. Which is also similar like this. If you are not understood, please let me know. I will repeat some steps if you want anything. Okay. So this three and this two, because it is on, we are computing from S class. Clear, sir. Okay. Okay. Let's move to another question. This is an last question we are discussing about. Also, this is related to the table which we have shown earlier. Okay. Using a new bias classifier determine that the person with efforts lots, okay, and confidence no be hired. So here you can observe the GPA is not provided. Only the partial attributes has been provided here. Based on these partial attributes, can we find out that this particular person which is an hired or not hired? Yeah, please try to solve this question and let me know which could be the option is correct. It is this person which has an effort is lots and confidence is no. What could be the that person particularly is hired or not hired? Yeah. Mm, some students are still joining. Yeah, Sandhya, do you have any doubts? Okay. Is there any guess for this question? D. Both classes are equally likely. Let me know which, how much probability you are getting for this, for the class hired or non-hired. Considering this equation or this condition, that is an effort slots and confidence no. Okay, yeah. So let's discuss it. The D option is correct, that someone has stated that the both classes are equally likely, or it is an hired or it is no. The examples cannot be correct. Let's see which one is correct. So here, as already stated, that we need to compare the probability uh, of hired, given that the efforts is lots and confidence is no. We need to identify this probability. Also, we need to get the probability for not hired, given that efforts is equal to low, right? Efforts is a lot, sorry. Confidence is equal to no. Okay. So let's first see about the first one, the probability of hired, given that efforts is equal to lots and confidence is equal to no. So we can write this like efforts is equal to lots, right? And the, what you can say, the um, confidence is equal to no, given that, second, given that is no, given that it is an hired into a probability of hired, right? It's a simple conditional probability we have considered. So this term, how we are calculating it, the probability of efforts is equal to lots, given that it is hired, into probability of what we can say, the confidence is equal to no and hired. Okay, so as we can consider directly, I'm taking the values which is amount. So you can calculate how we can calculate it. Let's take as in from S class. S class is, and so hired we have already calculated, right? Probability of yes, which is an 3 divided by 5. Out of 5, how many are the how many are the uh, lots? How many S? One, two. This one is no, right? 2 divided by 5. 2 divided, sorry, 5 no. 2 divided by 3. 2 divided by 3, right? So this one is for, and also we'll multiply with the confidence is equal to no, is for S, how many time? It is one time only, right? So 1 divided by 3. 1 divided by 3. 3. Hello. Yes, Harish, you have any doubts or any confusion? Okay, yeah. So I hope you guys getting. We are getting the probability for the effort slots is and 2 divided by 3, and probability for the confidence no for S class, higher class, which is 1 divided by 3, and 2 uh, 3 divided by 5. We are getting approximately point 133. Okay, so this is for the probability of we are getting for this class, this category. Okay, so this is an 0.133. Okay, so let's calculate for this category what could be the probability. As we have seen that, uh, so that same I am writing here, efforts is equal to lots, and I'm directly writing it is not hired into probability of confidence is equal to no, and it is and not hired. So this whole into probability of not hired. Right? Not hired, we have probability which is about 2 divided by 5, right? Yeah, and this one is uh, that already calculated. I don't know. Yeah. So the efforts is and lots for the no. You can see the efforts is no only one, right here. Here one, lots no. So it is about 1 divided by 2, right? Two no's are there. Total number of samples are there. And for no, confidence no, how many for no, here is no 1 divided by 2, right? 1 divided by, which is equal to zero point 0.1. So here we are getting a zero point 0.1, and we are directly, you can observe here this value is greater, right? That means it is a higher. So the option A is correct here. Okay. Yeah, I hope you guys understood. If you have further doubts, please let me know, or otherwise, you may write me an email as well. Okay, that's it for today. Now, these questions we have discussed a broad way to cover the what has been taught in this lecture, this week 3 lecture. Okay, all the best for the assignment 3. Okay, we'll see you in next week, Friday. Thank you. Yeah.